Good evening, everyone. So, uh, are you able to hear me and see my screen? So, good evening, everyone. Welcome to today's session course Digital Design with Verilog. So, this is week one. So, today we will start with first with the switching algebra. So, if we consider the switching algebra and with binary, so we have a set of 1 and zeros. So, the basic gates are and, or, and not gate. So just drawing the, like, I will write the truth table for this. So if we consider AND gate consists of two inputs. And the two inputs x, and it is represented as x dot y. And OR gate consists of again two inputs, x plus y is the notation, and the NOT gate is one input, which is x complement. So let's write all the four combinations. So this is the truth table for the AND gate. When both the inputs are 1, the output is 1, otherwise it is 0. So similarly for the OR gate, when any one of the input is 1, the output is 1, otherwise it is 0. And complement, when input is 1, the output is 0, and vice versa. Okay, so with this we will see some basic properties of switching algebra. So the first property is indemnification property, which says that x plus x is x, and when you perform the AND operation with x, it is x. With the same variable, if you perform the OR operation or the AND operation, it gives the same input. So the next property, complementation. When you perform an OR operation with its complement, it gives 1, and when you perform an AND operation with its complement, it gives 0. The next property, commutativity, that means x, if you perform OR operation, x or y or x both are same, and similarly x and y or y and x both are same. And next property, associativity. If you perform first x plus y, that is x or y, and then perform OR with the z with the resultant, or you perform x and first you perform y is Z, or then with X. Both are same. As well as you perform AND operation with X and Y. First or Y and Z, and then with X and then with Z. These are equivalent. Our next property is distributivity. So if you perform X and with Y or Z, this AND operation is distributive. So X, Y and plus or X and Z. Similarly, OR is also distributive with this AND operation. So it is like equivalent to X plus Y or X plus Z. And also this one, if you consider like, let me take some example. So just this property to explain the principle of duality. I hope you will be knowing that we have to interchange OR gate with like AND gate and AND with OR, and constants 0 and 1 with 1 and 0 respectively. So if we consider this, so say this portion, this property distributive, so X OR should be changed with AND, Y OR to AND will be I am replacing OR with AND. So we obtain this particular distributive from the principle of duality. So similarly, it holds for 1 is changed to 0, 0 is changed to 1, and OR is changed to AND operation. So you can apply for the okay. So with this, next property we have covered till distribution. Next, absorption law, where X plus XY is equal to X and with X plus or with Y is equal to X. And similarly, X plus X complement Y is equal to X plus Y. So this gives X. This too you can get it with respect from the principle of duality. The next theorem, consensus theorem. Sorry. Which states that X or Y, X and Y, or X complement Z plus Y and Z. This is equivalent to XY plus X complement Z. And similarly with the OR. Like this can be obtained by replacing the AND with OR and OR with AND operation. And the next principle or theorem in evolution, that is, if we have complement of complement, will be the same variable. So with this, next we will go to De Morgan's theorem. So if we have x plus y the whole complement, this gives like we have to break this complement. So x complement y complement, and then we have to change the sign. And similarly x y, if they are in AND operation, change the sign and break the complement. So this is with respect to two variables. Okay. With this we will take one expression. Okay, I will do it in a slide. Expression simplification. So if t is x complement, y complement or z complement, the whole complement, plus x complement, y complement plus x complement, z complement. So solving this, first let's just remove the complement from this whole term. So x plus y we will keep as it is. Next x complement of complement will be the same variable, and y z plus the same x complement y complement plus. Okay, now x and y, x plus y, we can take it inside this bracket, like apply the distributive theorem. So x plus x y z plus y x plus y z plus x complement y complement plus x complement z complement. And now x plus yz plus simplifying in this portion again this gives 1 is equal to x plus okay. So at this, let us solve some previous year assignment questions. So which one of the following is the idempotency property of switching algebra? Here x is the switching variable. So can you try this question? Yes, it is true. So a variable could remain unchanged when it is AND with the same variable, or sorry, or with the same variable, or AND with the same variable. Okay, going to the next question. Find the equivalent expression of x y complement plus x complement y z the whole complement. So here we have xy complement plus x complement y z whole complement. So we have to apply De Morgan's theorem here. Okay, so first is x complement plus y. This I am changing and do to or. Next is x complement is same plus y complement plus z complement. Yes, any doubts? Any doubts? Someone raised your hand, I think so. So I will just repeat this. So x, y. When we want to break this complement, this one. So we will change this sign and here one complement. Okay. So now again x complement, change the sign, y complements complement. Again this is AND operation. So x complement plus again y plus z. Yes, expression simplification. So first here you can take x. I'll take some other color. X plus y z plus x complement is common, y complement plus z complement. So anywhere you can apply consensus theorem. So sorry. This step, if you take x plus this 2, so x is common, sorry, yz is common, 1 plus x plus yx. Okay, so now this reduces to x plus yz plus yx. And from this you can observe anything, apply the absorption law. This, sorry, not this, this and this, x plus yx, if you apply absorption, it is equivalent to x. So you get x plus yz. So you arrive at this step. Till here it is, I hope it is clear. Then I think I will do again from first. The expression is x plus y, x complement, y complement, z complement. So first step was to break this complete complement and change the, so x complement complement, change the sign, and this also change the sign, complements complement. Next, x complement y complement plus x complement z complement. And next we have to apply distributive for taking this inside. So x plus xyz plus yx plus yz. This much is one term and this is the same term. So next, in this whole term we want to reduce it. So x plus, if we take yx common, it is 1 plus z plus yz. And then x plus yx plus yz. So in this, if we apply absorption, it is x plus yz plus x complement y complement plus x complement z complement. Now try to apply some their consensus theorem, or any absorption is possible. I think if you reduce from this x complement, and this reduces to x plus x complement with y. If you apply this theorem, x plus x complement y is equivalent to x plus y. So this plus x complement plus this whole thing as y will give to x plus this whole thing, which is y complement plus z complement plus yz. So with this we come to this step. I hope it is clear now. We apply this theorem here. Absorption. And from here, again it is x complement plus this gives to x. This one you can take x plus y. This and then reduce it further. So by applying absorption law, you will be able to get. I don't have place. I think I can use it here. X plus y complement plus z complement plus yz. So again, x plus x complement y gives to x plus y. This is the absorption law. So this. Anywhere you can apply this too. Which should give z complement plus y plus this one y complement plus x. So y plus y complement is equal to 1 and output is 1. I think somewhere I made mistake in this step. So I need some space. I'm just writing this equation here. From this now you have to apply absorption to this y z plus y complement if you apply. Or you can apply with anything. Okay, just distribute this y complement plus y comp y complement plus z plus this also you can perform, and this gives to 1 plus something which is equal to 1. Either try to absorb this y z somewhere or just distribute y complement with y z. Or other thing you can try is you can distribute y z plus z complement. So you will get y plus z bar again z plus z bar. And again the answer is 1. So is it clear? Expression simplification. So just repeating it again. So first you have done is distributed this x plus y with this term. First we applied the De Morgan's theorem here. Then distribution of this x plus y. Then we started applying the absorption law. So here is x y we have taken common. That is again 1 plus c is equal to 1. So next we have applied the absorption here and we got this. From this we can either distribute this y complement with yz or z complement with yz. Both the way we will get either z plus z complement or y plus y complement, which is equivalent to 1. So 1 or with anything is 1. Clear? Shall we go to the next question? Consider the switching function. X complement z plus x z complement plus x complement y complement. So if we apply this two set of values, what will be the function output? Yes, so first let us apply 0, z is 1, odd with x is 1, 0, odd with 0, 0. So this gives 0. The next set of values, x complement 0, z 0, plus x z complement plus x complement y is 1 because we have one value. So it is option B. Okay, fine. So next topic we will go for is the canonical forms. So canonical forms. So first we will start with sum of product. So what is a min term? Which contains each of n variable and in the either complement or uncomplemented form. And so how many possible min terms? So there are 2 to the power n possible min terms for a function f. So SOP, the sum of all min terms derived from those rows for which the value of the function is 1. So in the truth table, say if this is the output and these are the inputs. So this is some function consider. So considering this terms, whenever the output is 1 and writing in the sum of a product, sum of all the min terms. So this is 0, so this is min term 1 and min term 3 and this is denoted by a symbol summation. Similarly we have for canonical forms for product of sums. So a sum term that contains each of the variable in either a complement or uncomplemented form, it is a max term. So in the min term it is a product term and that is like if I want to represent this as A and B, so it is like A complement B or A B. But whereas here it is the sum term. So if I take the same A B and its output, so this now we will be considering this term when it is 0. Okay, so in the each max term a variable xi appears in the uncomplemented form if it is 0, that is A complement, sorry, uncomplemented form, and this is also 0, so plus B, so you can see it is a sum term, and next is when it is 1, it should be in complement form. And this is represented as symbol pi, and the max term 0, max term 2. Or you can just write pi, I think we will follow the same notation, pi 0 comma 2, and this can be represented as sum of 1 comma 3. So let us take some example. Canonical forms. So if we consider the decimal equivalent, and x, y, z, 3 variable function with output f. So we will have 8 combination. So considering this, implement some logic, and this is the truth table. The decimal equivalent. So from this, I will reduce this length. Yes, if you want to write SOP form, sum of product, so f of x comma y comma z is given as whenever it is 1, and if it is 0, it should be in complement form. So this is for 1, and this is x complement y, z complement for the decimal equivalent 2, next decimal equivalent 3, and decimal equivalent 6 plus decimal equivalent 7. So to represent this, we use summation 0, 2, 3, 6 and 7 whenever the function is 1. So for POS, the function is considered when it is 0. So that is, and also when the value is like 1, it is 0, 0, 1, so it's x plus y. When it is 1, it is in complement. Plus, and next when it is 0, it is 0 at 4. So x complement plus y plus z. Plus next, not plus, it's product term. It should be product, and again it is at 5. So x complement plus y plus z complement. So if you write as product term, we represent with the symbol pi. It's 1, 4 and 5. So next, if we have some term, say t, x comma y comma z, x complement y plus z complement plus xyz. Now we want to convert this to SOP form. Canonical SOP form. So that means every term should contain, like now in this the missing term is z, so we have to take multiply with zz. complement.
In
In
this
this variable,
both
both x and y are
not there,
not there,
so we have to
multiply with
x
x
plus
plus
x bar
x bar
as well
as
as
well
y
as y
plus
plus
y
y
bar
bar
and z
and
bar
z bar
plus
plus
x
x
y
y
z.
z.
This
This
is in
is in
proper
proper
minterm.
minterm.
Now
Now
apply the
apply the
distribution
distribution
theorem.
theorem. Plus. So I have distributed x bar y z plus x bar y z bar plus now this term. I am distributing x y z bar next x y bar z bar plus x bar y z bar plus x bar y bar z bar plus x y z. So now you can see each and every term has all the variables either in the complement or uncomplement form. Similarly, if you want to convert to canonical, yes, POS form. So let's consider another example. Any doubts? Okay. So we are converting this to canonical POS form. So again now if we observe x complement, we need the product term y. So we will multiply with add with y complement, and z is also required. And in this product term we need x, so x complement. Now we have to apply distribution theorem. Next is x complement plus y plus z complement. So with y we have distributed next with respect to y complement. So x complement plus y complement plus z plus x complement plus y complement plus z complement. And plus okay, four terms we have distributed. This portion is done. Next, this distribution. So x plus y bar plus z is one term, and x bar plus y bar plus z is another term. So this gives is the simplified POS form. So every term consists of all the variables like x, y, z in the complement or uncomplement form. So any doubts till here? Okay, so we have already seen this theorem in evolution. Theorem which states that x complements complement. If you complement the same variable, it gives x complements complement.
Now, if
Now,
you
if we
want to
want to
convert
convert
SOP
SOP
to
to
POS,
POS,
what
what
is
is
the
the
expression? We
expression?
can
We
say
can say
XYZ
XYZ
as
as
X
X
complement
complement
Y
Y
complement
complement
Z
Z
complement
complement
plus.
plus.
If
If
this is
this
the
is the
expression,
expression,
then
then
what will
what will
be
be
its
its
POS?
POS?
So this
So
is
this is
000, which is
which is
equal to
equal to
the
the
decimal
decimal
equivalent
equivalent
0,
0,
decimal
decimal
equivalent
equivalent
1,
1,
decimal
decimal
equivalent
equivalent
3.
3.
Yes,
Yes,
any
any
doubts?
doubts?
Yes, if
Yes,
you
if
have
you
any
have any
doubts, you
doubts,
can
you can
unmute
unmute
yourself and
yourself and
also
also
ask.
ask. Sorry,
This
this
is
is
0.
0.
So
So
the
the
expression
expression
T is
T is
equal
equal
to
to
T
T
complements
complements
complement.
complement.
Okay.
Okay.
So the
So
T
the T
complement
complement
consists of
consists of
those
those
minterms
minterms
that are
that are
not
not
contained
contained
in the
in the
expression
expression
for
for
T.
T.
Okay,
Okay,
so
so
from
from
this,
this,
what are
what
the
are the
minterms which
minterms
are
which are
not
not
considered
considered
here?
here?
0,
0,
1,
1,
2
2
is
is
not there,
not there,
4,
4,
5,
5,
6,
6,
7. So
7. So
these
these
two
two
terms
terms
will
will
be
be
in
in
the
the
POS
POS
form.
form.
So
So
6
6
is
is
110,
110,
means
means
X
X
plus
plus
Y
Y
complement
complement
plus
plus
Z,
Z,
X
X
complement
complement
plus Y
plus Y
complement
complement
plus
plus
Z.
Z.
So
So
this will
this
be
will
the
be the
POS
POS
form.
form.
So
So
next
next
we
we
have
have
just
just
so
so
there
there
are
are
total
total
2 to
2
the
to the
power
power
n
n
coefficient,
coefficient,
and
and
each
each
of
of
them
them
have two
have two
values.
values.
So for
So for
each
each
of
of
which
which
can
can
have
have
two
two
values,
values,
which is
which is
0
0
and
and
1.
1.
So
So
hence
hence
there
there
exist
exist
how
how
many
many
switching
switching
functions?
functions?
2 to the power 2 raised to n. Yes.
Yes.
Two to
2
the
to the
power,
power
2 to
2
the
to the
power
power
n
n
minus
minus
n,
n,
not
not
minus
minus
1.
1.
I don't
I
know
don't know
why
why
they
they
said
said
minus 1.
minus 1.
2 to the
2 to the
power, 2
power
to the
2 to the
power
power
n,
n,
switching
switching
functions
functions
of
of
n
n
variables.
variables.
Uh, is it
Is it
correct?
correct?
So
So
till
till
here,
here,
any
any
doubts?
doubts? Okay, so if we consider the next gate exclusive OR gate, so okay, explain again the converting SOP to POS form. Yeah, so SOP to POS, when we in the SOP canonical SOP form, we will consider the whenever the output of a function is 1, those min terms will be considered. So here in this expression, like in this output is 1 for 0 1 and 1 1, that is min term 1 and 3, and 0 means it will be in complement, 1 means it will be in uncomplement form for the SOP expression. So it is A complement B plus AB. And the same truth table, if you are expressing as the POS form, the term where it is 0 in the output will be considered, and if it is input is 0, it will be in uncomplement form. If it is 1, it will be in complement form. So A for 0 0 it is A plus B, for 1 0 it is A complement plus B. Now coming to the expression which we solved as an example, yeah, converting. So this consists of the min terms summation 0 1 3 7 5 and 4. So the min terms left uncovered in this are 2 and 6, so which will be in the POS form, and this is obtained because yes, we will share this presentation, and this video also will be uploaded in YouTube, and we will share the link. So I will write here. So the T is equal to T complements complement. Now if we take the complement of this expression and then complement it, the inner complement, this complement will give the terms which are not included in it, which is like x complement y z complement plus xy z complement, now whole complement. Again, so De Morgan's theorem, x plus y plus z, x complement plus y complement plus z. So I hope this is clear. This is just the explanation, and min terms which are not which have the 0 value are considered in the POS, and which have 1 we are considered in the SOP. So I hope your doubt is cleared. Yes. So let's go to the next. So this is the representation, symbolic representation of the exclusive OR gate, and its expression is given as x complement y plus xy complement, and it is represented using this symbol. So properties for this XOR, it is commutative, that means A XOR B is equivalent to B XOR A. Next, associativity, that means based on the order of evaluating the expression. So first you perform A XOR B, then perform the C, or perform A, B and C. which is equivalent to A XOR B XOR C. And next is distributivity. So AB XOR with AC is equivalent to A and another property is that if A XOR B, this is equivalent to C, then A XOR C is equivalent to B. B XOR C is equivalent to A, and A XOR B XOR C is equivalent to 0. Why? Because A XOR plus A XOR B is C. Now if you perform with C, it should be equivalent to B. This expression, we know that this till this A XOR B is equivalent to C. This gives C XOR C, which is again 0. Okay. So going to the next question. Sum of the product representation of a switching term x plus y plus z. Yes. Yes, correct. So let us just solve this. So x, we need y term, and is a term here. X term and is a term. So if you multiply inside, like multiply in sense apply distributive theorem. So this is in the expression A. Okay, so the next question. Find the product of sum POS form of the function. So first we have to see is what are the terms included. This is 1 0 0. This is equivalent to 1 0 1, 1 1 0, 1 1 1, 0 1 1, 0 1 0. So this is equivalent to 4, 5, 6, 7, 3 and 2. So this includes in the summation 4, 5, 6, 7, 3, 2. So the POS should consist of 0 1, 2, 3, 4, 5, 6, 7 are included here. Yes, so it's x plus y plus z x plus y plus z complement, which is option C. Clear? So, any doubts in this question? In this question, before moving on to the next question. Yeah. So the next question, consider the XOR operation. Yes. So x is equal to y XOR z. This is given. Next, z XOR x. Yes. Any doubts? Yeah. You have any doubt? Okay. So this we cannot say whether it is 0 or not. Similarly, this also we cannot give the, like, we cannot comment. So the next possible is x plus y plus z, whether it is equivalent to 0 or 1. Let us see. This is equivalent to x, and we know this is 0. Why? The XOR expression is, this is the expression for XOR, x exclusive order of y. So if you apply this x, it is what is this one? 1 and with 0 or 0 and with 1. Okay. It is equivalent to 0. Yes, the correct answer is option C. Okay. So with this we will go to the next topic. Functionally complete operations. So a set of operation is said to be functionally complete, or it is also called as universal if and only if every switching function can be expressed entirely by means of that operation from that set. So the one of the set is all the basic gate, and or and not. This is the basic gate. So any other set should be able to implement this function, and or and not. So this is another set, and this is another one more set, and NAND is a universal gate. NOT is also an universal gate. Okay, so the question is, which of the following set of the operation is functionally complete? Yes, any doubts? You can unmute yourself. Yes, option B is the correct answer. Why? We have to implement the NOT operation then it is NAND of A comma A. So A, we will get the NOT operation here, which is A complement. And now if you want to implement an AND gate using the NAND gate, so it is like NAND of A comma B comma NAND of A comma B. Means we need to say so this is A B A B. And similarly, if we want to implement an OR operation in using a NAND gate, so it is implemented as NAND of A comma A and sorry, I think we need one more NAND. Yeah, NAND of A comma A and NAND of B comma B. That is equivalent to like A B. So here we will get A bar B bar, and this will be A bar B bar whole bar, which is equivalent to A plus after applying the input system. Okay. So we observe that NAND gate we can implement not and or. Okay. So till here any doubts? If not, we will move on to the we will go to the next topic, which is on number system. Just wait for some 2-3 minutes. Yes, so till here any doubts, or next we will discuss on number system. So before that, any other doubts or questions? Yes, so shall we go to the next topic? So number system. Let's start with the decimal number. So if we have a decimal number, say 123.45, how we obtain is the every place value, radix or the base of the system is 10. So this is will be raised to 0, 1, 2, minus 1, minus 2. So plus 2 into 10 to the power 1, plus 3 into 10 to the power 0, plus 4 into 10 to the power minus 1, plus 5 into 10 to the power minus 2. So that is n is equivalent to A q minus 1 b raised to the power q minus 1. That is a place position value. So these are like weighted number system. So if we have A0, B0, B raised to the power, it will be 0. And now if you have any fractional part, say minus p position, it will be raised to the power minus p. So this can be given as value ranges from minus p to q minus 1 for ai bi. So coming to the conversions, when the base of the first number, like given number, is less than the base of the number to be converted, that is like 4.432.2, it is in octal. If you want to convert that to a base 10 system, we have to multiply with the position value. So 8 power 2, which is 0, 1, 2 minus 1 plus 3 into 8 power 1 plus 2 into what 0, and this gives to 282.25. So this way you can convert any number system lesser than the decimal value, like 10, to the decimal number system. So now again, if you want to convert this binary number to decimal number system, so it will be 1 into 2 to the power 2 plus 0 into 2 to the power 1 plus 1 into 2 to the power 0 plus 0 into 2 to the power, like, I think this should be 1 because it's binary. This is minus 1, this is minus 2, 0, 1, 2, 3. So 0 power minus 1 plus 1 into 2 power minus 2. So what will be the value? 13.25 in decimal. So this conversion, I hope it is clear, from any number system to the base 10. And this number system like base 8 or 2, which is lesser than the decimal. So the next case, like if we have base 10 and we want to convert to base 8 or base 2, that is the given base is more than the base which we want to convert, like say 580, it is in base 10. What will be the equivalent in octal? So we will perform the division with the base that we want, 8. So 68. This is from decimal to the required base. Okay. So this will be remainder 4. Remainder 4. 8 8s are 64. So remainder 4. 8 8s are 1. So remainder 0. And while writing, we should write in this order. Next conversion. What will be the equivalent in base 6? Any answers? So what will be the remainder, first remainder? If we multiply with 57, it gives remainder 3. Correct? Then next, if we multiply with 9, 54, again remainder 3, 6. 6 again 1 into 6, 6, 3 is the remainder. So it is 1, 3, 3, 3. Okay, so what will be the valid digits for base 6? It will be 0, 1, 2, 3, 4, 5. Okay, and valid digits for 8, base 8, which is octal. Okay, now if we have a fractional part, how to perform the conversion. So if we have 0.3125 in base 10, how to convert it into base 8? What will be the method used? So we want to convert to base 8. So 8, we should multiply with 8, and this portion before the decimal point will be our a minus 1 bit position. Okay, now we have already taken 2, so the left bits are 0.5 multiplied with 8, which gives 4, and this no other decimal value. So minus 2 bit position is 4, and this we will write in this order. That means it is 0.24. Is it clear? So if we have 0.375 in base 10, what will be the equivalent in base 2? So again now the required base is base 2, like 2. So we have to multiply with 2, which is 0.75. So a minus 1 is 0, and 7, this is equivalent to 1.5. So a minus 2 is 1, again 0.5 into 2, which is equivalent to 1. So a minus 3 is 1, and we will be writing in this order. So this is how we will be converting the fractional part to the from the like base 10 to binary or base 10 to octal. Yes, it is 0.011. Okay, next conversion. Binary to octal. So if this is the binary equivalent, to convert to octal, the octal system, we will be forming the group of 3. Why 3? Because we want to represent 0 to 7, and the digits required are 3 digits. So if we consider this as the binary number, so while writing itself, I am writing as a group of 3. So this is in binary. What will be the equivalent of in octal? This is 2. You can add one, append 1 0. 6, 1, 5, 3, 7, 4, 0, 6. So the equivalent is 26153.7406. This is in the octal number system. So we can observe that the values valid digits are 0 to 7. Okay, now if you want to convert binary to hexadecimal, Here we will be forming the group of 4 because the valid digits are 0 to 15. This is 15 is represented as F, which is 1111, and this is 40. So I think when writing, I can write as a group of 4. So we can append two zeros. This is equivalent to 2, 6. No, it is 8421 is the base of the system. So 8 plus 4, 12. 12 is equivalent to C. 6. This is again 8421. 10 plus 1, 11, which is B. And F, this we saw before, 2. So this equivalent is 2C 6 B dot F 2 in base 16. So till here, any doubts? Now let's convert octal to binary. This is in octal number system. So now we have to write in a group of 3 binary format. For 6 it is 110, next 7 3 digits 30, next 1 2 4, again 3 digits, clear? So the next we will do hexadecimal to binary, which is 306. So 3 is we have to represent is the group of 4, 0 and 6. Point, what is the equivalent of D? 8, 4, 2, 1. So A is 10, B is 11, C is 12, D is 13. So this is the equivalent in binary. So any doubts still here? Let's go to some questions. Okay. Is equivalent to with yes. So is equivalent to which of the following number in base 10? So we have to convert to base 10. So it is like 2 to the power 0. 0, 1, 2, 3, minus 1, minus 2. So it is 1 into 2 to the power 3 plus 1 into 2 to the power 2 plus 0 into 2 to the power 1 plus 1 into 2 to the power 0 plus 0 into 2 to the power minus 1 plus 1 into 2 to the power minus 2. So it is 8 plus 4 plus 1 plus, which is equivalent to 13.25. Yeah. 13. Any doubts? Yes, option A. Okay, going to the next question. Which of the following binary number equivalent to this? So we are given in the decimal. We have to convert to binary, so we will perform long division. Divide with 2. So we will get 216. Remainder is 0. Again divide it with 2. Remainder is 0. Again 2. 54. Remainder 0. 2. 0. 27. 2. 13. Remainder is 1. 2. 6. Remainder is 1. 2 3s are remainder 0. 2 1 1. And we have to write in this way. Yes, option C. So the next is 0.375 into 2, which is 0.75. So the decimal part before the fraction is 0. And next is 0.75 into 2, which is equivalent to 1.5. Again 1. So 0.5 into 2, which is equivalent to 1. So 1. And this we will write in this order. So it is 1 1 0 1 1 followed by 4 0 point 0 1 1 in binary. So okay, I hope this question is clear. Going to the next question. Which of the following octal number is equivalent to this? So octal we have to write as a group of 3 1 0 1 0 1 .001 and this is 1 0. So we have to append one more 0. This is equivalent to 1 4 6 5 6. 656.14. So any doubts? Okay, so we will solve some more questions. So if we have, consider this convert 132, consider it is in radix 4, convert this to radix 5. So let's first convert this to decimal. This is from one of the gate questions. So let's first convert to the decimal. 1 into radix 4. So 4 to the power 0 1 2. 2 plus 3 into 4 to the power 1 plus 2 into 4 to the power 0. So the decimal equivalent is 16 plus 12 plus 2, which is equal to 30. Now we have to convert this decimal to radix 5. So what will be the approach? It will be the long division by the radix which we require. So 6 5s are 30, no remainder. 5 1s are 5, 1 is the remainder. So it is 1 1 0. The answer is 110. So is this clear? So we are trying to convert from radix 4 to radix 5. The base of the system is from 4 to 5. Okay, next question. If we consider x and y are two decimal digits and 0.1101 is in in binary, is equal to 0.8 xy5 in decimal. So what is the value of x plus y? Can you try? So what will be the value of first this value? X and y or the decimal equivalent, and what is the value of x plus y? How we will convert this 0.1101 into decimal? This is minus 1, minus 2, minus 3, minus 4. So 2 to the power minus 1 plus 2 to the power minus 2 plus minus 4. So it is 0.5 plus 0.25 plus 0.0625. So answer is 8.125 in the decimal equivalent. So x plus y is 3. Yes, x plus y is 3, correct. So going to the next question. If this is in the base 5, which is given as x8 in base 5. So what are the possible values of x and y? So what will be the approach? If you want to convert this to base 10, like base of the system, we want both the 5 and y to be in the same base system, so that we can solve. Yeah, one of the solution is x is equal to 3, y equal to 10. Any other possibilities? Okay, so x y to the power 1 plus 8 y to the power 0. So this is like 25 plus 10 plus 3 xy plus 8. So the first set of equation is xy should be 30. And next, x is the number and y is the base of the system. So y should be always greater than x. So when you're like trying to find the equation, so if we have x is equal to 1, y can be 30. If x is equal to 2, y can be 15. X is equal to 3, y can be 10. So these are the possible values for x and y. 4, it is not divisible. 5, so you can, okay. Next is x is 5. Is it possible? X is equal to 4. Like these two equations should be satisfied. Okay, so the next question. If the given BCA9 is in hexadecimal, what will be the equivalent in octal? So we have to perform hexadecimal to octal number conversion. So hexadecimal group of 3, 4. So first is 9, A is 10, so 1010, and C is 12, so 1100. Next is B, which is 11, 1011. Okay, next is group of 3. So what is the equivalent? 1, 3, 6, 2, 5, 1. So it is 136251 in octal. Sorry. Okay. So the next question. Consider the equation 43 with base x, y3 with base 8. So the number of possible solution is so again we will convert to the same base, so let's convert to decimal. X 4 times x plus 3 is equivalent to 8 times y plus 3. So we get 4x is equal to 8y, x is equal to 2 times y. Next, any other condition? X, so x should be 4 should be less than x, or x should be greater than 4. Okay, from this side, and from here y should be less than 8. So y should be less than 8. So these three equation should be satisfied. So the first solution can be x is equal to 6, y is equal to 3, Next is x is equal to 8, y is equal to 4. Next is x is equal to 10, y 5, because x and y, x is double of y. If it is 12, then y should be half 6. And if it is 14, next y cannot be 8 because it should be less than 8. So possible solution 5. Okay. So any doubts till here? The previous year assignments or the questions that we have solved now, and also any other concepts. So any doubts or any questions? Yes. No doubts? I'll wait for 1 or 2 minutes if you have any doubts. Okay. Okay, if no doubts, then we can end today's session. Thank you so much for joining. Okay, so if no doubts, I will end the session. Yes. Okay, thank you so much. I will end the meeting. When will be the next class? Next class will be again Tuesday, 6 to 8 p.m. Every Tuesday, 6 to 8 p.m. Yes.
Okay, I'm ending the meeting. Thank you so much.